Good morning, friends. Today we are going to start with digital multimeters. This is basic circuit of digital multimeters. In the previous lecture we have studied digital voltmeter, digital current meter. Current can be measured using D'Arcy meter or galvanometer, and the same instrument can be used for voltmeters, whereas in a voltmeter resistor is connected in series, and for a multi-range voltmeters number of resistors are connected in series, and in a current meter you will find resistor is connected in parallel with the circuit. If we want multi-range current meter, then resistors are connected in parallel and there are such multiple resistors connected, which is called current measurement. In a D'Arcy measurement or in a galvanometer type of measurement, according to current, if current increases, it deflects more in the D'Arcy meter or in the galvanometer. As current is 1 ampere, accordingly deflection will be 1 centimeter. If current increases to 2 ampere, deflection will be 2 centimeter. If current increases to 3 ampere, deflection will be 3 ampere, and so on. That means as current increases, deflection in the galvanometer changes and it increases. It is used for current measurement, and this is called a meter. As far as additional circuitry are concerned, we have to limit current flowing through the coil through a resistor, and that's why current or resistor should be connected in shunt or parallel. That is called a current meter measurement. For the voltage measurement, if resistor is in series, then current is converted into voltage, and voltage can be measured using galvanometer. This is basic principle of voltage and current measurement. I will draw a circuit of voltage and current measurement here. If a resistor is in parallel with the circuit, then we apply a voltage at the input side. This R is there, number of resistors are increased in this fashion. So this is called digital voltmeter, and if resistor is in parallel, current is connected over here, current and resistor is in parallel, R1, R2 and R3. This is the case, then it is current measurement. In the multimeter both are combined. In the multimeter both are combined means here resistor comes in series, this becomes your voltmeter. If resistor comes in parallel, it also becomes your resistor also comes in parallel, and this also becomes your current meter. This is a circuit in which DC input is applied, then this series of resistors are there. This is another resistor Rin which increases input impedance of the FET. Here we are using FET because FET is having high input impedance as compared to BJT, and accuracy will be more. FETs can be used at two places. This is FET, and this Q1 and Q2 are dual transistors or balanced bridge, which forms a balanced bridge. Q1, Q2 is forming one arm of the bridge, R1 and R2 forms another arm of the bridge. Resistance R3 is zero balance resistor who adjust bridge balancing using who adjust scale of deflection at the center. DC is supplied to give supply to FETs and output is measured across this deflection or this galvanometer. If current is voltage we want to measure, DC input voltage, suppose 1 voltage applied, it is 1 volt voltage is applied, then current flows through this. As this is a resistor, I will show you which type of resistor it is. It is this type of resistor. That means 6 mega ohm, 1.2 mega ohm, 600 kilo ohm, 120 kilo ohm, 60 kilo ohm and 20 kilo ohm resistors are connected over here. Why this is in series? It avoids more number of resistors. Whatever the ranges is there, we will use resistors in series. So suppose if it is in the 12 volt range, resistor 6 mega ohm and 3.3 mega ohm comes in series and it forms 12 mega ohm range. That means 6 plus 9 mega ohm voltage comes to this. So resistance is more and so we can use more voltage to the input side. For 30 volt, 6 plus 1.2 plus 3.3, that is 9.3, 10.5 comes in series. 10.5 comes in series, that is 6 plus 3.3 plus 1.2. This resistor comes in series. For this, as this resistor increases, voltage range also increases. Current limiting occurs due to more voltage and hence this is the voltage changes. So this type of series resistors are there in the circuit. If DC input is say 1 volt input, it is directly connected to this point and current flows through this R, or only 3.3 mega ohm resistors comes in series and it is directly connected to the transistor Q1. This 1 volt voltage is transferred, current is flowing through this gate and it is also through the capacitor. More current will flow through this. More current will flow through this. So maximally 1 ampere current it will measure. It comes across this. As this imbalances our current, R1, R2, Q1, Q2 resistance, it balances initially, which is at 0th position. As current increases, this deflects. Transistor Q1 current also increases and hence it will deflect the needle of galvanometer, and this deflection is directly proportional to the current flowing through this Q1 arm. Now if we increase this current to 2 ampere, then it is more current flows through this and more deflection will occur through this deflection needle. If current is increased to 3 ampere, then limiting current occurs through this, and range is different, range is second, then more current will flow through this. So current limiting, and as far as ranges of FET and galvanometer remains same, but if current is up to 30 ampere, this resistor range itself will limit that current, and current is passed through more number of resistors, but in the galvanometer same current should pass. There should not be overflowing current through the galvanometer, otherwise galvanometer will go out of range and there will be burning of transistors and meter happens due to increase in range. For the 300 ampere range, definitely this MOSFET and galvanometer will burn. So for this range we will use initial more resistor, so that limiting current will flow through this circuitry and towards FET. So this is what a balance bridge DC amplifier is. DC amplifier, and which is used as a input circuit to the input current or voltage to the DC voltmeters, and it is measured on DC voltmeters as shown in the figure. So DC multimeter is a DC voltmeter again. This voltmeter is of this range. As far as ohm is concerned, ohm also can be measured using this circuitry. Current also can be measured using this circuitry. So this is nothing but a DC voltmeter, DC or ammeter, in which current and voltage can be measured on a single circuitry. We will see next true RMS meter in the next lecture. Thank you.